Hello, my name is Blake Robinson, and in this video I'm going to be going through the Python code that I wrote for my Deck Comparisons program, which is available on my website. I did create another video that goes much more in depth on what this program does, but to give a real brief outline as to what we're looking at, basically in this program it takes deck lists as URLs and provides data for each of the deck lists that can help facilitate pre-game conversations to check whether or not the decks are going to be balanced to play against each other. So for each deck list, we calculate the cheapest printing budget of the deck, we calculate the salt score of the deck, we calculate the average mana value of the deck, and we calculate the number of competitive level cards how many competitive level cards are in each deck. For more information on each of those, please go check out the other video. But in this video, we're going to focus in on the actual code that we wrote. So first things first, I'm going to go through the libraries that we've used to make this work. So first, very importantly, we import JSON. EDH Rec uses JSON files for their website design. I connect to MTG JSON to collect a lot of pricing data and card information. So this library, hugely important. We're also sending, we're basically collecting those JSON dictionaries through requests. So that's why we import this. Date time, this more is just for myself. I wanted to see what parts of my code were taking the longest to process to see where I could optimize. So that's what I was using this for. MTG SDK is it's a library that just stores a lot of information on cards. So this was a really quick way of being able to pull up. You'll see that each printing of a card has a unique ID. So Sol Ring has been printed 100 times, meaning that there are 100 unique IDs for Sol Ring. So with this library, with the card feature, you're able to say, okay, when card name is equal to Sol Ring, what are all of the unique IDs associated with that card? Next, we have MTG Parser. MTG Parser takes, it's a really useful library for parsing deck lists. It supports a bunch of deck building websites, so Aether Hub, Archidect, Moxfield, Tapped Out, all of the major deck building websites are supported, and you can basically input a URL, and it'll spit out the corresponding deck list as a list. So super useful. And then finally, we use regex in a lot of this code. While MTG Parser is great at grabbing the deck lists, we need to clean that data up, and we do so by using regex. So now to actually get into the meat and bones here, we start off just by grabbing URLs. So we create a list of URLs, and that's how the program starts. In this section, we start a master list variable. And this is basically the single variable that we add all of our data to in order to run our tests. So the reason I wrote it like this is because this is a program that I am continually improving upon. So anytime I want to run a new test, like for example, right now I'm working on trying to add a combos feature to this deck, where I check each deck list to see if there are any combos present. And what I could do here is I could do master list equals combos, and then put in that master list. And basically, this combos program would just return, whether or not it sees any combos in the list and what those combos are. So this is really where all of the testing happens, and let's just go through each of these tests one at a time. So we start with this get list function, and that is present here. We start by opening a quick pricing JSON file. So when we send a request over to JSON, to the MTG JSON all prices file, it's like a 3 gigabyte file. It is absolutely massive. It takes each card printing and figures out the buy list price and the sell list price, or the retail price, for each printing for the past 30 days amongst each retailer. So it's absolutely massive, and it takes a long time to sift through all of that data. So here's what that looks like. You can see here's a card's unique ID, and then this is saying here's the Card Kingdom buy list price for the foil version of the card for the past 30 days. Here's the retail price for the past 30 days. Here's the TCG player retail price for the past 30 days. And the buy list price for the past 30 days. And the card mark, right? So on and so forth. So this was way too much information. It was taking too long to go through. So I wrote this separate program called Update Files, which basically sends a request to that all prices JSON site, and parses all of that information down into only what we need, and creates this JSON dictionary here. So basically, for each ID, we're pulling the TCG player price of the current day, and we pull both the foil price and the normal price, and record that information here. So this file is, probably a tenth of the size, if not less, and makes the program run. It used to take about 2.5 minutes per deck list in order to pull the pricing information, and this gets it down to about 20 to 30 seconds per deck list. So very useful here. And then basically once we have the pricing file open, we go ahead and use that deck list parser library that I had mentioned at the beginning, and we use that to parse to basically pull in the deck list for each URL. So when we get the deck list information, it's dirtied with a lot of information that is useful, that is important, but it isn't compatible with the rest of the program. So we have to clean it up. First thing we do is we check to see if any of the cards have a commander tag. And if they do, we add the associated card with to a commander list variable. So we're checking for the commander tag here, and then we're removing quantity information, we're removing set information, basically a bunch of stuff that we don't need. And then here we add it. Then we check to see whether a card has a maybe board or a sideboard tag, because we don't want to be pulling data from maybe board or sideboard cards and counting it towards the data of the deck. So we pull those cards out here, and then if the cards aren't in the maybe board or the sideboard, we store the quantity information in this line of code, and then we remove the quantity information. We remove any of the tagged information. So sometimes people will add tags to their deck lists. So they'll say this card is in the draw category, or this card is in the ramp category, right? So removing that information here. We're removing any set information. So We're moving, hey, this is, printed in Rivals of Ixalan, or this is printed in Commander Masters, or whatever it is. That is removed here. And then finally, we're adding the card name. We're creating a deck list variable, and we are adding the quantity and the card name to that deck list. If it's unable to pull any information, then we're going to do error checking and say, hey, we're unable to find your deck list. Next thing up, we go ahead and we check to make sure that there is at least one commander selected for the deck list. If not, we do error checking and it'll send an error back to the website. And then if your deck list only has one commander, which usually that'll be the case, it just sets the name of your deck to the commander list. And if it has more than one commander, then we are setting basically both of the commanders as the name of your deck list, just by adding a hyphen in between. This part of the code is just used right when you run the program. It allows you to identify which data is associated with which deck. So if your commander is Kenrith the Returned King, it's going to pull Kenrith, set it as your commander name, and then display Kenrith the Returned King next to the rest of the data. Next up, once we have those deck lists created, we're going to use that MTG SDK card feature to pull the unique IDs. So for each card in the deck list, we first check to see whether the name of the card is Plains, Island, Swamp, Mountain, or Forest. We don't want to pull pricing information for that. First of all, there have been multiple hundreds of cards printed for each basic land type, and they're typically not counted towards the budget of a deck. So we're pulling out all of that information. We're basically first checking to see if it's a basic land, and if it is, we set the IDs to none. And then here's where we're using that card class to pull the unique IDs. So we basically input the name, and we grab all of the associated IDs with that card name. Now we have to go through each of the IDs and validate that those IDs have pulled correctly. And so this might seem a little counterintuitive here, but this was really important to get accurate pricing data. So basically, for each unique ID associated with a card, we check to match whether the name that is associated with that card is equal to the card name. You might be thinking, why are we doing this? This seems like a dumb extra step. Well, here is an example that I pulled up. I was testing this code with a few of my decks, and I was running the card Vigor in one of my decks. Vigor is a $10 card, and unfortunately, it was pulling the unique IDs associated for each printing that had a card, that basically for each card that had the word Vigor in it. So Rapid Vigor is a $1.08 card. Invigorate is a 16-cent card. So it was not calculating card prices correctly. So what we're doing here is we're saying, okay, we're first checking to make sure that if I'm running the card Vigor, that the unique ID that I'm pulling, the name that is associated with that unique ID, is just Vigor. And if so, then we add it to the official unique ID list. If for whatever reason it's unable to pull any ID for the card, and where this may happen is double-faced cards. I'm not sure if it handles double face cards correctly, but there's also cards like cards that have adventures or whatever. The deck list parser and this card class handle those situations separately, differently. So this is basically saying, okay, if there are no unique IDs associated to that card name, then instead we're going to ignore this check and just add all of the IDs associated with it, which is a little bit risky, right? I've tested this with a ton of double face cards, but fortunately, when we look at double face cards, there's often like slashes in them, and those typically aren't present in other card names unless it is the appropriate card. So, so this is basically just saying that we still want to pull the pricing data for a card if we're unable to find a unique ID where the name matches what the parser pulled out. I know that can be a little complicated. If you want to follow up with me, I'm more than happy to go deeper into this. But this was just a lot of validation to make sure that we are pulling the correct card names. After that, we're first checking to see if none exists within the unique IDs for the card. And if so, we are setting the price of that card to none. Why are we doing that? Well, two reasons. One, if it's a basic land, we want to set the price of the card to 0, and we've made the unique ID's card price none, so we're able to just do that here. Additionally, cards that are brand new may not have pricing data associated with them yet. So so if there isn't any pricing, we're going to catch that here, and we're going to set the price to none. Next up, we're actually going to be grabbing the price of each card according to this pricing file. So first things first, we are basically for each unique ID that we have tagged to each card, we are checking the normal printing price and then the foil printing price, and we are adding that to the potential. We're basically adding that to this prices list, right? So we're keeping track of each price of each printing associated with the card, and then we're basically calculating the minimum price that is present in this list and associating that to the price of the card. If there are, for whatever reason, if there is no pricing information available, we set the price to 0. Again, this is just to catch for any new cards, or in the future if they print something that if they print a card that has names that are listed in syntax that I'm unable to catch with the current program. We don't want it to just run. By default, we're going to set it to 0 and then be able to update this program in the future to accommodate whatever Wizards of the Coast may do. Finally, for each deck list, we have basically created the pricing information, and we have the quantity, card name, and price of each card listed in this deck list variable. So we're going to add that to the master list. We're also going to take the deck list URL, the commander list, and the commander name, and just add that to the master list. So again, this master list variable is just housing all of the data that we're using to make this program work. Next up, we've got our deck analysis program. This is basically we start off by sending a request to that atomic cards file. As a reminder, the atomic cards file is just this database here, this JSON database that has each name of a card. It basically sorts it by each card name, and then it provides all the relevant information associated with that card. So it'll pull the mana value of the card, the salt score, the power, the toughness, oracle text, keyword abilities. Bunch of information is stored for each card on this database. So we are using that database in this program basically for each. So for each list within the deck list, we are instantiating all these variables, and then for each card within the deck list, we are pulling the mana value of the card and adding it to the total mana value. We're also checking to see, we're basically filtering out lands here because we don't want lands to count towards the average mana value of the deck. So we're looking at the average mana value of non-land cards, and so we're pulling that information out here. We grab the salt score of each card, and then we basically send that information back into those master lists. So we pull the average mana value, here we pull the total salt score. We keep track of what the saltiest card is here, and the saltiest card value, and we add that to the list, and then that's it. Send that back, and then the last test we do is we send that master list into the CEDH test, and we do the same thing. So we start off by sending a request to, or I guess actually what we're doing is we parse this deck list using that MTG JSON, using the MTG parser library. And this is basically a list of 230 of the most commonly played competitive level cards. Basically, it analyzes deck lists that have been submitted to tournaments and creates a list of CEDH staples. So what we start with is we start by parsing that CEDH deck list, and then we do a real simple regex function here, which basically pulls out the quantity information and just leaves us with the name of the card. And we append that to this CEDH staples list. And then for each deck list, or for each card within each deck list, we basically check to see whether that card falls within the CEDH staples. And if so, we set a CEDH tag to that card as true, and we update this overlap count. And then that's what we're left with, right? We're left with each card in a deck list having a true or false, basically a Boolean value, checking whether or not it is true, is a CEDH card or not. And then we have this overlap count here. After that, we're basically, we have two things left to do. One is display the data for each deck, and two, make suggestions if it catches any imbalances. So just real quick here, I do calculate the total budget of each deck and add it. I could easily add this to the get list function, but I just have it here for simplicity's sake. And so let's just go through this one at a time. First, we display the information for each deck. So we get the deck name, the budget of the deck, the salt score, the saltiest card, the mana value, and the number of competitive level cards. Then we check to make sure there's more than one deck list that has been submitted. If so, right, there's no point to trying to check for suggestions if there's only one deck list. So if there's only one deck list, we just want to submit this information, the kind of bird's eye view data. But if there's multiple deck lists, we're going to start the check to see whether it can catch any imbalances. So basically what we do is for each test, so this is like the budget test, right? For each test, we're going to sort the decks from the cheapest budget to the most expensive budget. And then we're going to see if the difference between the cheapest budget deck and the most expensive budget deck is $250. If it's more than, greater than or equal to $250, it's going to raise a flag and say, hey, this is a budget consideration. We need to make a suggestion that decks should be playing similar budget decks. Then we're going to go, specifically, we're going to look at the most expensive deck. We're going to check if the most expensive deck is $125 more than the second most expensive deck. And if it is, it's going to make the suggestion that deck consider switching to a more budget deck. Similarly, we check the cheapest deck and the second most cheapest deck, and we check if the difference between those two is $125. And if so, it'll say that deck should consider switching to a more expensive deck. If it's unable to specify which deck should make a change, basically, let's say that there's 2 really expensive decks and 2 cheap decks, or if they're all just, if let's say one deck is $100, one deck is $200, one $300, and one $400, right? 400 minus 100, the difference between the most expensive deck and the cheapest deck is $300, which means this flag gets it checks out. It says, hey, there's a budget consideration that we need to make, but the difference between any deck is not greater than $125. Therefore, it says, hey, we need to make a suggestion, but there is no specific deck we can call out. So instead, we're just going to make this blanket suggestion that all players should consider switching to decks with similar budgets. So I spent a lot of time looking at this first one. All of these tests do the exact same thing, right? We sort on salt score, we sort on mana value, and the thresholds are just different. So for salt score, we check if the difference between the least salty and most salty deck is 20, and then the difference between any 2 decks is 10. And then with mana value, the threshold is 1 and the difference is 0.5. And then finally, the CEDH count, check to see if any deck is playing 20 more competitive level cards than the deck that has the least. And then if the threshold is 10, it calls out the specific deck. So last but not least, we just provide card level information if people are wanting to look at that. So here shows the prices of each card. Here shows the salt scores of each card. Here shows the which cards are considered competitive in each deck. And that's the entire program. So I know that was a lot to go through. If you have any questions or recommendations on features you'd like to see created in this program, I'd be more than happy to talk with you. All of my contact information, as always, is on my website here. Feel free to reach out, and I hope this program can help enrich your Rule Zero conversations and make them more driven by data as opposed to, just like the gut feeling of what your deck is. So anyways, I look forward to hearing from y'all, and have a great rest of your day. Bye-bye.